Hello, in this video I'd like to show you how to create a persistent container in Docker. Now you might be wondering, containers are designed to be ephemerals, to be created and destroyed, disposable, lightweight, isolated, easy to create, easy to destroy. And there's a feature here that shows some of the properties like the life cycle, data storage, use cases, advantages and disadvantages in terms of having some containers running in your environment. Technology is going towards that direction, infrastructure as a code and things like that. However, not for everybody, but maybe some folks, personally I use it, found the need to have a persistent container like a small VM that can be shared with teams. It can be long life, continue running, even when the container gets stopped. The data storage, sometimes I've seen it done with the data persist, not necessarily mapping a volume from a third-party dependency. It could be done in the same machine. And again, it's not for everybody, just for some use cases. Just bear with us, follow this video and find out. Services need to be considered available. Databases, yes. For us, scripts or some repos, Git repos, or some status of devices or curls or APIs or whatnot. It's reliable, persistent, and it's going to be very easy to start and stop. Faster to stop and shut down, faster to improve performance, they increase the resilience, just a process on the kernel, simplify management, and it's cost efficient. So, with all that said, let's go ahead and get started. This is going to be containerized with a Docker containerization engine Linux. We're going to be relying on some of the Docker Hub repos to download some of the things, in particular Debian. This machine that I'm running in virtual environment is Debian, and we're going to be using Debian container, but you can use Alpine, Alma, Slackware, any other distribution, Ubuntu, Debian base, Ubuntu, etc. Just the Arch Linux, whatever distro works for you. Oracle Linux, hosted by VirtualBox. VirtualBox provide Oracle Linux, provide us the virtualization on VirtualBox, which is I think a fantastic engine for the testing technology. Thank you on that one, Sun Microsystems on that one. That's cool. And this video is recording with the share exportable version. I think I have the 12 dot something. The one is not as clever, but with all that out of the way, let's go ahead and get started. This is some of the things, contribution from GitHub and the Git actions for the Docker Compose. So let's go ahead and get started. I show my environment. It's just VMware, VirtualBox, and this is actually a connection into that box right now. I don't have nothing in the existing machine. Really, I log in as a user. That is called dinooz, and the installation is going to go as follows. For your container, it's going to be assumption that the Docker is installed. I'm going to give you a bonus. I had to add a user to run containers, otherwise you're not going to be able to. The bonus is going to be the Docker Compose. Run a couple of Docker commands. Some of those might use example to show in Portainer, how Portainer is going to be running for us when we get it going, and how we do the containers that live forever and eventually I can be working and running on that. Some other options that are containers that don't live forever. It's going to be like we can run in while loops into the bash, but I think this is, again, let's go back to the principle, complexity, reliability, and flexibility. What is really the best thing we're looking for? And of course you can use Docker Compose to create a Docker file and Docker Compose up. In this case, it can be using the supervisor D to monitor a particular configuration files, or via volumes. You can actually mount the volumes with external, create a volume on the file system, or do bind mounts, or name volumes like Portainer does it, and eventually map the local drive to that. That's another techniques, but we want to go for the simple one. We want to be with a kind of a Linux way of doing things until device known. That's when I give the magic and you won't believe it. And eventually, let's go back about persistent Docker containers, complexity, reliability, and flexibility. So with all that said, let's go ahead and get started. I want to demonstrate that Docker PS is running. Docker V running version 20.10. And right now, if you have a user that want to be able to run Docker, extremely recommendable for security. You don't want to run as root. You want to do containerless, rootless containers as user, any kind of user. In this user is going to be added to the Docker group. And just to be more verbose here, if I look at etc group, we can see that actually in the installation it was created Docker. It created a Docker container, which is there. The only thing you have to do is actually use the usermod command. In this case, let me make dinooz. I did that already, but I have another user that is my user. Let me create a user dinooz part of the AD group. As you can see, it's not right now. When I add the command, the user mode add group docker dinooz, I can do the cat on the same file, and now, well, I'm part of the sudo. I'm part of the sudo users as well. I should be able to. Yeah, I'm part of the sudo users. I probably won't need that anyway. But if we have another user like user dino2, that's here is at the bottom. You can see docker use dno and user dinooz. I'm able to actually, if I just kind of etc group, I remove the user dinooz is no longer part of the. I can just do su dinooz docker ps, and you have an error. You cannot have permissions to connect to the demo. Now, if I do su dno docker ps, he can run the actual containers. If I modify that, and I can either you add the group, you execute the command. The command is easier, just kind of avoid mess up with the operating system. I can just add user mode and cat etc group. You can see that I'm part of the Docker group, and as being part of the Docker group, I have access to the socket. I'm user Unix and docker ps. Voila, I'm working fine. So that's the bonus thing. Security, always add the users to group and Docker version. Now the other part is actually the Docker install command. Typically installation Docker compose, it doesn't get added. So what you have to do is actually curl some command on the user local bean compose. You link together to the user local bean and use security wise chmod 755, otherwise they won't have access to the users. Basically that's pretty straightforward. Just to download a link, a binary. That's the one I have hard time. Some of the notes show the wrong link, some spacing in the documentation, but I want to put the notes in the video so you can actually follow along. Of course, this command failing because the link exists. The only reason it has to be done is like force it and create it, and that will be able to actually execute it with no problem. Getting this started with Docker, we can actually show the images. Let me change as the regular user. Let me change as the user DNO, which is the scope of this exercise. And now we can do docker run hello world, and I can say docker ps docker images. It's actually a Debian and a portainer, just I downloaded previously. I can do docker run hello world. It downloads the hash. Now in Docker images, I see that I have a 13K hello world, 117 meg Debian Docker image, and a portainer container. So that's the way you can actually do. If you want to do, let's say you want to do Docker pull Debian, that's what I did, and you want to do maybe Alpine Linux, and you want to play around with the Alpine Linux distribution, you can just do docker pull Alpine. It would download your version of Alpine in hash, and eventually when you do Docker images, you'll be able to see that you have a Docker Alpine, that you'll be able to successfully 7 meg, super small, super easy to run. In this one, you can potentially do some kind of Docker run interactively, Docker exec, interactively, the name of the image, I guess it's going to be the image ID. We don't put any names, the image ID is this hash, and eventually we can do in bin bash. docker exec did not like. If I do the same, something similar in docker exec, you have to put a name probably. We have to modify. Let's keep one forward on the portainer. We come back to this one, but we have the doc image. We hadn't run the alpine in a second. For now, when I create as root, I like to suggest to do this as root because it's the main portainer for your volumes. Create portainer data, and then we have it created. You can mount it somewhere else, but and we can run the portainer. This is going to be interesting to see how I actually execute everything, because what it's going to do. Did it run? The other command was the one it didn't took. docker.ps. It did run. Okay. So notice here the ports that are mapping 8000 and the port 9043. The port 9000 actually is actually the one we wanted to actually get running. Let me stop this one. Docker stop. This is actually the one it runs the wrong ports here. I really don't want to run this. I like to run this one, which is going to be mapping to the port 9000 on the. Let's go through this, shall we? Docker run dinooz in the port 9000. Name of the is going to be portainer. Restart always in case something goes belly up with the var socket and the var running sock. The volume is portainer data, the one we created earlier. Is going to be running the image data portainer-ce, which is a community edition. So as you can see, we have that one in the images, so it didn't took anything to actually get the latest one. It's flagged the same, but it's actually portainer-ce. And then we can do docker.ps, and we can see effectively has 14 seconds ago running and in port 9000. So right now, if I go back against containerize this one on Debian, I can just go to the settings on port 9000. That's the one is actively, and go to the port forwarding rules. I want to add a rule for the port 9000, 127.00.1 on port 9000, 110.0.2.15, which is the default port that is being used here for the containerization. And I want to bring back the browser. The browser, this is the image on the link on we download on the Docker Hub. And let's go ahead and move now to the port 9000 on the browser. And here we go. We have it. We have to create a password. I don't know. You can do something on the fly. It's going to be deleted anyway, so it doesn't really matter. You create your user, and that's all good. Get started. You can see in portainer you got the containers running. Right now we have only the container running. We'll see how one of you start running more containers as we go to this exercise. I wish you can toggle and just remove this one. But anyway, I can just open my browser, but you won't see that window. Anyway, a portainer is running, and you can run stacks. You can actually run something really cool here. You can add a stack. You can actually put a web editor and literally paste your Docker compose and see everything. They have done a fantastic job. This is I think this is portainer.io, like the MySQL admin for MySQL back in the day, in the community edition, as you can see. So if you go through the commercial, you need to do it. You need to pay the license and everything. So that's how you can contribute to that project. But for now, let's carry on. So we have a portainer running. Let's go ahead and see the magic of this one. We wanna Docker run a container called Debian 1. Actually, you know what? Let's go ahead and do the first one. Let's keep this running on Debian 1, and basically it's going to be in the detach mode. It's going to be run the Debian in the container. It's going to be detached, so we don't have to be. It's in the background. You won't have to be connected to continue running. It's going to run the image Debian, the latest one, the one we have in our repo, and it's going to execute the command tail and that's following device null. What is that? You want to be warning. If I run tail, if I run the command, we copy this one with like a secure CRT or something. If we run this one here, tail-f device null, it's only going to be, it's kind of dummy a command because its tail is follow the changes on a file when something changes. But if it's device null is nothing. It's like zeros. Never is going to change. Device null is device null. It's dead. It's done. So that's a silly command, but it's actually a loop. So if we run the run rocket command, let me just change the user to the regular user, and let's docker -b, docker ps, and docker images have access to everything, and even docker compose. Nice. So I'm gonna execute the command docker run debian, and it does really quick. It took nothing. It's running a container running and name it called Debian. So I'm running Debian on Debian. It's kind of silly, but it is. So let's jump into the docker exec interactively on Debian 1 on Vim bash. And here we are. I'm root, but I'm root from a container. Take a look. This is a root of the container ID. If I do the ls home, let's add the let's add a user. I'm trying to think some good names for a users. The users of a band, or the users of state, the users of a car or color. Let's do colors. Let's do red, blue, and white. So I want to add user blue. The password is blue. I want to add user red. Password is red. I want to add user white. Password is white. Fat finger. So ls home, we have red, blue, and white. We got 3 users. I can become those users. Nice. So what happens if I exit from the container? The container is still running. Tail, device null. No matter what you do, you can put a cron job, you can put a ping, you can put whatever you want. The container is going to continue running for as long as this process stay alive. But I can do, you will say, I can do docker stop, and I want to put a container ID that I want to stop. This is going to actually stop the container from running, and once it's there, we'll be able to see it in the dorm. There we go, docker ps. I'm not able to execute the command anymore to jump into the bash shell because it's a stop, right? It's not running. What happens if I do now docker run what it was running? Docker start and the container ID, and now it's running. And if I do and jump into the container again, the users are there. How cool is that? All right, so Any files that I create persistently, I'm going to continue leaving there. Let's repeat the same exercise, creating another image, which is going to be, I could do the command slightly different, like just shorter, like name Debian2, that's detach Debian on the tail, so I don't have to actually go for all the details about latest, or you can just do Debian. It's going to reference my name of the local image is going to be this. It's going to be a shorter command, similar, but I want to have two containers, and look how fast it is. Docker ps is there. Now it's running the Debian 2. That's pretty cool. Which is another process. I'll show you in a second. Now let's run a third. That the only thing different than the it's going to be the persistent container is going to be bin bash. So let's see how that behaves. I got 3 containers, 1, 2, 3, which is actually like a virtual machines. Let me jump into number 3 in particular. That's the one is getting my attention. Is the one at the top. I can just do, I guess we can just use this. Jump into the containers. Docker, I imagine like I become sudo user on that user as Debian. I'm root. ls home, of course there's nothing. Let's create some users. Let's create some users, which is colors. The user, let's use green. Password is green. And let's create a yellow, like the Brazilian flags. Nice. We got users green and yellow. Cool. But check this out. If I exit docker ps, docker stop, and we stop Debian 3, which is the one with the yellows, it's going to take some time. It's going to stop the container, which is fine. It's not going to be showing my Debian 3 is not running as a process. It's not running as a container. Docker start, and the same container ID that I stop, like I did earlier in docker container 1, and it's going to start again. But this is what is ephemeral. I can jump and exec interactively to Debian 3 bin bash. I become root, home, and your users are still there. Wow. It was on the previous version that it was not running an ephemeral. Something must have been changed. Well, it's good to know. Maybe the newer releases have been changed. This was not behaving like this before. But it's on a good video. Still, I'm happy to see this. I was pretty sure because I run early versions on the image and the images were gone. And of course, if we jump into Debian 2, there's not going to be any users. Yep, expected. And if I go to Docker container, well, I'm happy to hear that this is fixed. Must be in the new releases. I have to do some research. Anyway, I was pretty sure in the previous versions that I did it. I noticed it didn't preserve the changes, but but the command is hold on. The command is doing the tail is doing still the same command. It's doing a tail command on bin bash. That's the problem. The command is not, it should not be tail fvim bash. That's the problem. Never mind. I was just let's create this work on the tailvim bash. I didn't know tailvim bash, which is ridiculous because vim bash is nothing. Anyway, I guess that's another hack. I don't know. Let me create a Debian 4, which is going to be Debian 4 running. The touch is going to be the image Debian. It's going to be vim bash. This is the classic way that actually be there. Let's create another two colors. For a second, you scare me. I say, what happened here? So let's go ahead and create another run image Debian 4. It's only execute Debian and vim bash, and that's not going to keep the colors. Okay, so it did not want it to run. It did not want it to run. Why did not want it to run? As that's getting a real puzzle. I know the fact. I know that was the fact that actually we have that issue. Something exit code. That was a different. Why? Because vim bash is not working. Let's figure out real quick. That's the reason why the tail vim bash. I guess I found something else new. So I learned something new today. Let's see if it takes the parameters. There's a sleep infinity. docker.sock has interactive. There's the case that actually we can run Debian, run docker.sock. You can just run the command, I guess just like the other one, just like you jump into the container, you can just run exec. That's interactive Debian 5 on vim bash. And if you do one running, not running but executing like that, you can exit code. Interesting how exit the code, because it's not docker run, it's docker exec. This failed. Any rate, we'll be able to demonstrate in Debian 5 how can we actually execute a fifth container. I'm as a user, vim bash, docker exec. It did never create a run does name Debian. Let's see if we can run some other. Another sample here for Debian 5. Docker run does interactive Debian 5. Of course, do docker run, that's his name, Debian 5. I don't want to do dash remove because that will delete it at the exit. Let's see, just for a really quick test. That will delete it when we exit, so it's not going to be fun. Whatever we do is going to be remove it, and the other one is actually going to be removing, not removing. Let's see if we remove that. We just go for that. Yeah, I know I want to be there, and whatever I do, cd home, other user gray. And when I exit, docker ps doesn't show nothing because we told them that actually was deleted, so it deleted an exit. There's no way we can get it back. Now if we do without the with the deleted, just interactively, Debian, I guess we should be able to run this one first, but anyway, that doesn't matter. Now we run Debian 5 interactively with temp file system, and then another color, let's say purple or crimson tide. There you go. So now we have a user crimson. If I exit, I can see that it's gone. So there's no persistency. Again, nothing working. If I do docker stop, the very first one we did 15 minutes ago, it doesn't matter what time, it's going to take some time in the process, and then we go back, docker start, and then we use it to start it, or users are going to be there. Oh, we need to jump into that, right? We need to jump into the exec it debian 1 bin bash, and then there you are, red, blue, and white. Good. So now if we go back to the main system, we see that actually we're running the regular container-ce, container-ce, part of docker. We have the docker proxy. All those process ID are those process from the users, the window manager, SSH, systemd. But really, in the eyes of Docker, or in the eyes of the operating system, it's only process IDs. That's all it is. And even better, if I do system controller status docker system controller status stop docker, that's going to be pretty intense on the operating system. It's going to stop everything, so nothing on the docker process is going to be continue running. And if your docker containers were actually done, let me see status. It takes some time maybe to stop, but my containers are gone. Now if I try to run the container again, docker it says on Debian 1, it's not going to be nothing there. It's not running. Okay, so now system controller start docker, which we enable, right? This is a status docker. Okay, su does dinooz. And let's repeat the last command we did. Right, to start the processes. I don't know if they were flagged to start automatically, like we did in portainer. Portainer maybe seem to be running again. It's actually access to log in to admin. That's what we did at the beginning of the video. But here we go. As you can see, the containers are not started. 1, 2, 3, 4, 5. I can use this one to start really quick. And seems like now we're getting some synergy going on. So if we go back to the CLI, docker ps, there's my images, there's my files, and then there's my colors. Cool. That's exactly what I want to show you. Non-ephemeral, persistent containers. Hopefully you like the video. Hopefully you like it. You have some comments or something, please let me know. I want to try to make not stay out of the glitch. I've been learning a bunch of good stuff, a lot of the span leaf, VXLAN, VNIs, everything with Cisco World. I like to share some of that. I've been learning some of the cool things about the documentation with LaTeX, but it's going to be a coming video. Give a thumbs up if you like it, recommending, commented. Always looking forward to hear from you. Hopefully have a great end of the first end of the quarter 2024, and thank you for listening, thank you for joining, and give a thumbs up if you like it. Have a good day.